This course is related to the troubleshooting for DigiEye280. In the course, we will learn some typical cases to study how to analyze and solve the problem. The first case is the generator start failure, and its phenomenon is that when placed one key button on the system control box, the generator cannot start up, and all the electromagnets have no response. So, how to analyze this problem? First, from the table power box circuit, we can know that the table power control box power comes from the bucket in the baseboard, so it may be no output from the bucket in the baseboard. And the second, the generator did not start up. It may be the system control box have some problems, but the PC can start up, so we need to check the cable from the system control. And from this circuit, we know that the generator startup signal is from the system control box to the main control board by this cable. The X6 to the J17. So we need to recheck the cable and replug in, then restart the system. The system becomes no. And the second case is the warming information display after the power cut off and reboot the system. Because of the power cut off suddenly, the Windows system may occur some problems. So the warming information will be shown to the system recovery. And for the old PC, the warming information is Chinese, but this button means the recovery, and this button is cancel. So if you meet this situation, you can click the cancel as above. And if the hospital always power cuts off, we suggest the hospital to install a UPS for the PC. And the power of the UPS is about 500 watt. The third one is to change the transformer input according to the actual situation. During the mechanical installation, the engineer has to check the output from the power distributor cabinet and check whether the transformer's input terminal in the generator is connected correctly according to the output of the PDC, such as the output of the PDC is 440 volts. The transformer input cable has to connect to the terminal of 440 volts. Otherwise, the PCBA boards may. From this circuit, we can know that the transformer can receive different inputs like the 380 volt, 400 volt, 415 volt, and the 440 volt. We have to change the cable according to the actual situation. Okay, the next typical case is after exposure, the Windows system give a warning information. TODO file description has stopped, and at the same time, the DROC give error E22 timeout for waiting image. So, how to analyze this problem? First, from the E22 error timeout for waiting image, it means that the system is always perform the image post-processing, but it can't see the images. So, in last, the E22 error will be occurred. And from the engineer, we know that before this problem, the engineer just so according to above information, the issue is maybe the dictator calibration have some problem. So we need to repeat the dictator calibration. And after the dictator calibration again, the problem is solved. So we have to pay attention to the dictator calibration. First, the SSID should be 1.3 meter. So for DigiEye280, usually we put the dictator on the floor. And the second, the collimator light must be cover the whole dictator. And the best is open the collimator window measurement. If the dictator placed on the workstand for the calibration, we have to remove the grid first. The next troubleshooting is about the tube rotation failure. For DigiEye280, after this ECR, we got a new version of table power box. And the customer feedback, the brake for the tube rotation is failure, but the other brakes are normal. So, according to the customer's feedback, all the brakes are available except through the tube rotation. So, before the engineer go to the customer site, we suggest the engineer to apply the tube holder assembly parts for backup, because the rotation brake is in the tube holder. And when the engineer on site, and we ask the engineer to check the voltage for the brake first, and the brake power come from the table power box on X27, and its normal output is 36 volt DC. The engineer tests it and it's normal. So the engineer changed the tube holder assembly, but the problem is still the same. And the last, we check the table power box circuits, and there are 3 relays inside the table power box. So we can exchange the relays, and when we exchange the relays, the tube from the situation on above, we know that the relay is defective. So apply the new relay and exchange. The tube rotation function is become normal. So from this case, what can we learn? First, we have to check the input of the brake. But even if the input is normal, but we still can give the assurance that the brake of the tube rotation is defective. And the second one, the relay for the new version table power box is a mechanical relay, and it is not compatible with the old one. And the new relay part number is, the number says troubleshooting is the image have the grid artifact, and it happened only the system config the Murray dictator. As you can see the picture here, like this is the grid. So why the image have the grid artifact when configure Murray dictator? Because the software for Murray dictator is different with the Toshiba dictator. When you select the dictator position on workstand or table stand, the post process have enabled the grid artifact process, and if you select the dictator position in the free position, the grid artifact process is disabled. So if you put the dictator on the workstand or under table position, but you still select the free position on the DROC, due to no grid artifact process, the grid artifact will display on the. So how to solve this problem? First, we can select the corresponding position in the DROC according to the actual dictator position, or we can enable the grid artifact process always available as below. Log out to the Windows desktop and open this file and edit this line. One, always enable the grid process, and 0 means the free position grid process is disabled. So we just need to change the 0 to 1. The next typical case is the system boot up failure. When we start up the system, the PC stuck in the dictator connecting screen, like the picture shows us, and reboot the system cannot solve the problem. So how we can? From the customer, we know that the system is normal before the problem occurs. So the system setting is normal. And then we try to plug the generator communication cable with PC on behalf of the PC. The cable connects to the COM1 and then restart the system. And now if the system can go to the DROC software, we can export the logs and check whether the G5 or G6 error is occurred. as you know, the G5 and G6 is transferred from the generator to the DROC software, and the transmission frequency is too fast, which results in the DROC software crash. And for these two areas, G5 means the battery power of the main control board is too low, and G6 means the generator tie area. So for this problem, we just need to replace the battery on the main control board. If you face this situation, first click the crop icon to select the whole image, then click the parameters to go to the parameter screen. If you press the parameters, it's not available. Please click the reprogress first, and when you enter this page, just click the apply to apply the progress, and then check the picture is okay or not. If not, please repeat the previous step. The last typical case is about the G104 error. When start up the system with one key start button, the PC boots up normally, but the software gives the G104 error and the generator. How to analyze this problem? First, check the power supply, the output of the main contactor, as the picture shows here. This is the input of the main contactor, and then check the emergency switch. Make sure the switch do not press. And the second step is to check the cable connection, like the system control box and the auxiliary power board, all the cables. If the below steps cannot solve the problem, let's continue. And during the generator startup, check whether the auxiliary contactor is pulled in. If the contactor do not pull in, check with the step 4. And if the contactor has pulled in, check with step 5. For step 4, if the auxiliary contactor do not pull in, first we have to check the J2 contactor on the auxiliary power board. Its location is here. This is the auxiliary power board, and this is the J2 connector. Check the value for the port 3 and port 4. If the voltage is 12 volt, check the system control box and the cable connection. Normally, this voltage should be. Next, if the voltage is 0 volt, then we have to test the voltage between the J1, the 5 port, and the ground. Normally, the voltage will be changed from 0 to 5 volt within 10 seconds. If they are 5 volt or continuous 5 volt, That means the charge signal is normal. So please test the control voltage of the auxiliary contactor, and the control voltage is 220 volt besides the contactor. And if the 20 volt 200 and if the 220 volt AC is normal, just please replace the auxiliary contactor. But if you cannot measure the 220 volt, it may be the auxiliary power board problem. If the J1 and the ground has no 5 volt DC, please replace the main control. For another situation, the auxiliary contactor is pulled in. So we have to plug the J5 connector first, and during the auxiliary contactor pull in, measure the J5 port 1 and port 3 voltage, and normally it's about 360 volt. If you cannot test the voltage, please replace the auxiliary power board. If you can test the 300 volt DC, just please check the buckle capacitors cable. About this area, and according to the experience, mostly this failure caused by below reasons. First, the auxiliary power board defective. Just replace this board directly. And the second one is the engineer forgot to connect the J2 on the auxiliary power board. And the last one is the emergency switch is placed on the system